Today, we are going to look at confidence intervals. We are going to use these to estimate the intervals for population propulsion. Before we start the construction, we are going to look at the things which are needed. Like we would like to know what are the point and the interval estimate, confidence intervals, confidence levels, and margin of errors. A quick recap of that, and then we go and look at the formulas and apply it to examples. So the first thing we're going to look at is a point estimate. Remember, a point estimate is a single number which is the best guess for our parameter. When I say the word parameter, guys, please keep in mind this remembers a population. For example, if you have this point estimate, so this is the population, it is one single number which represents the whole data set. Okay, as we're looking in proportions, so we're going to use a sample proportion as a point estimate for the true proportion. Now remember, this is not a very good estimate as it only gives one single number. So in these scenarios, as we have talked many times before, an interval estimate is a good one. Over here, we are going to look at a range of values and above and below the point estimate. And this range of values above and below is called the margin of error. This interval estimate is a very useful one as it helps in gauging the accuracy of the point estimate. And this leads us to a confidence interval. A confidence interval contains the most believable values for a parameter. It consists of three parts: the confidence level, which basically is including the uncertainty of the method, the point estimate, sample statistics, which is basically, and in our scenario, it is the sample proportion. And then the margin of error. So the formula looks like point estimate plus minus the margin of error. This is much more preferred than point estimates as it gives not only the precision but the uncertainty part. Now remember, the uncertainty part is the probability part, and we give a name called confidence level. So the confidence level is denoted by 1 minus alpha. This alpha is the chance that it will not cover the true parameter. So for example, if I say alpha is 0.05, then the confidence level is 0.95, which in turn means that we're 95% confident that the interval will cover the true parameter. Okay, let's look at margin of error. Now, margin of error measures how accurate the point estimate is likely to be in estimating the parameter. Now, it is further divided into two parts. One is the critical value, which is basically the z-score, and the other one is the standard error. The standard error, guys, is an estimated standard deviation of a sampling distribution. We denote it by SE. So the confidence interval, including these two parts of the margin of error, now becomes point estimate plus minus z-score times the standard error. Now, how do we interpret the confidence interval? This is a problem which I have talked twice before, and I'm going to say it again. Like if you would like to estimate the percentage of APSC students who are left-handed. Suppose the point estimate is 15% and the margin of error is 0.0587. So the confidence interval is point estimate plus minus the margin of error, which is 0.15 plus minus 0.0587. So that gives us the interval of 0.0913 and 0.287. So when we are talking in terms of the analysis, we're saying we're 95% confident that the true percentage of all left-handed students is between 9.13 and 20.87%. So that was a little brushing of things we have we are going to need. And now let's go and start the construction of a confidence interval to estimate a population proportion. A simple review of some sample proportions we have here. The first thing is the mean of a sample proportion. Now remember, sample proportion is denoted by p hat. So the mean of a sample proportion is the population proportion. That means mu of p hat, that is sample proportion, is nothing but the population proportion. The standard deviation of the sample proportion is the square root of p times 1 minus p over n. Remember, this n is the sample size. Okay, not only that, but the central limit theorem says as we increase the sample size, the sample proportion behaves approximately like a normal distribution. So look at these figures. So here's where the sample proportion is only, say, 1, or sample size is 1, and we increase it to 5. So it still skews a little bit better than the previous one. But if my n is 100, notice such a beautiful bell-shaped curve we have. Okay. So the confidence intervals for population proportion, we need certain assumptions. The assumptions are that we have a simple random sample and the NP hat, that means the number of samples times the sample proportion, should be greater than or equal to 15, and the number of sample proportions times 1 minus p hat should be greater than or equal to 15 too. Or what basically means is the number of observed successes is at least 15. So then when we write down the formula, it is the point estimate p hat plus minus z alpha by 2 times square root of p hat 1 minus p hat over n. Now this, guys, is the standard error. Remember that, okay? So the general confidence formula for the confidence interval for a population proportion, remember it's plus minus, is if the confidence level is 90%, the error probability, that means this is my alpha, and the z-score is 1.645. If the confidence level is 95%, the error probability, or alpha, is 5%. The z-score is 1.96. If the confidence level is 99, the probability error, or alpha, is 0.01 or 1%. The z-value is 2.58. Now there's a nice connection between the confidence level and the margin of errors. Notice what happens. In practice, the confidence level is the most, 95% is the most common choice we work with. But sometimes applications require greater or less confidence. So what we notice is that if we are 95% confident, so this is 95% confidence, guys, then this is the confidence interval. Now, if we increase the confidence interval to 99%, what happens? When we increase it to 99%, now this is our confidence interval. So the more confident we are, the more is the range of values. So what we normally have to do is, when we're doing these problems, we have to have a compromise between the desired margin of error and the desired confidence of a correct inference. Because the more interval we have, the more possibility we have for the true population parameter to fall. So what we see is, as the confidence level increases, the margin of error gets larger. Remember, this is the p hat, that's the middle is the point estimate. This is the margin of error, this is the margin of error. It is the margin of error, so confidence interval is twice the margin of error. Remember, this is margin of error and this is margin of error. Okay, so confidence interval is twice the margin of error. Now there's also a relationship between margin of error and the sample size. The margin of error for a confidence interval says it will increase as confidence level increases. whereas it decreases as the sample size decreases. Now you'll say where it is. So remember, margin of error is what? Z alpha by 2 times the standard error. What is my standard error? It's Z alpha by 2 times S sample standard deviation over square root n. So alpha, if alpha increases, margin of error increases. Both of them are having a direct relationship. Whereas if the margin of error increases, n is in the denominator, it will decrease. So they are going in opposite directions. That's an indirect relationship. So this is very, very important, guys. Okay, now a 99% confidence interval is always going to be wider than the 95% confidence interval. We just saw that here in this picture. Then a confidence interval with 200 observations definitely is going to be narrower than one with 100 observations. Remember, if the sample size increases, if this increases, the margin of error decreases. If the margin of error decreases, that means the confidence interval decreases. So they are all in a hand-to-hand there. So this is a very, very important slide for us, guys. Now let's go ahead and apply what we have just learned in problems. Okay, the first problem is, engineers at a bottle making factory are interested in estimating the percentage of defective bottles which are manufactured by the facility in general. To do this, they take a simple random sample of 250 bottles and find that 20 of them are defective. We would like to find a 95% confidence interval for the percentage of defective bottles that is manufactured by the factory and interpreted. Okay, the moment you see the word, it's a proportion. You see word percentages, that's how the key is. Oh, percentage, I'm having proportions. If it is something related to mean, you would see the word mean or averages over there. So percentage means we are having proportions to work with. So what is the formula here? It's P hat plus minus Z alpha by 2. The standard error is given by P hat 1 minus P hat over N. So this is the formula, guys, we will be working with. Now, let's go ahead and fill in the brackets here. So what is P hat? P hat is the proportion. So that means if there are 250 N, so N here is 250. So P hat is 20 out of 250, which is 0.08. Okay, now Z alpha by 2, because my alpha is 5%, which is, 1 minus alpha, 95% is 1 minus alpha. So alpha is 0.05, and Z alpha by 2, which we have already seen in a previous slide, is 1.96. So what do we do, guys? We just go ahead and plug in the values now. So the confidence interval is P hat is 0.08 plus minus Z alpha by 2, which is 1.96, square root 0.08, 1 minus 0.08 over N is 250. Now when we do the math, it's 0.08 plus minus 0.033. So the confidence interval, this is the confidence interval, guys, is 0.047 and 113. Oops. Okay. Now let's do one more example with sample proportions. Oh, I forgot. And how do we interpret it? So the interpretation says that we are 95% confident that the percentage of defective bottles manufactured in this facility is between 0.047 and 11.3%. So 4.17 and 11.3%. Okay, so in terms of percentages, it's 4.7% and 11.3%. Okay, now let's look at another problem. It says, how green are you? Now, in this one, when 2000 general social survey asked subjects whether they would be willing to accept cuts in their standard of living so as to protect the environment, 344 out of 1,170 said yes. So we would like to estimate the population proportion. So what are we going to do? The first thing is estimate the population proportion who would answer the question yes. That means point estimate, which is 344 divided by 1170, which comes out to be 0.294. Now, to find the margin of error, remember what's margin of error? Z alpha by 2 times square root p hat 1 minus p hat over n. Now, because we are having what? 95%. 95% means what's Z alpha by 2? 1.96. If you forget, go back to the previous slides. You will see it as 1.96. So 1.96 square root 0.294, 1 minus 0.294 divided by the number of subjects are 1170, which you get equal to 0.0261. So what is the confidence interval? It is p hat plus minus the margin of error, which is 0.294 plus minus 0.0261. So if we do look at the endpoints of the interval, it's 0.27 and 0.32. Okay, so these were the problems related to the construction of the estimation of a sample proportions. Okay, so we're going to look at one more thing, is that when we do problems, real life, we like to know how much is the sample size we need. A very big and important question. Suppose you are a researcher and you have to find out, you're doing a research for your class and you say, oh, I have to, talk to these many people. The question is, what is the minimum amount you need so that you will be able to get your data? So in order to do that, what we have to figure out is, what is the desired margin of error? So in other words, how close the sample proportion should be to the population proportion, if you're doing a proportion problem. And then we have to choose what the confidence level is to achieve that margin of error. In practice, 95% of this confidence intervals are the most common we use. Now, if you're doing for proportions, what's the formula, guys? Here's the formula. For a random sample of size n, for which a confidence interval for a population proportion P has a margin of error E, is given by this formula, P hat 1 minus P hat times Z square alpha by 2 divided by the margin of error square. Now, if we are not given a sample proportion or P hat, by default, we assume it is 0.15, the worst case scenario. Now, let's look for the means also. On the other hand, remember we have done construction for population means. So if we have for means, we see that the random sample size of n, for which a confidence interval for a population mean and a margin of error n is Z alpha by 2 times sigma over E square. So here we are assuming that we are given the population standard deviation. This is important. We are guessing that we have a population standard deviation. Very important. Okay, let's do some examples, guys. Let's look at the proportion problem. So this is the proportion problem. How many students do we need to survey to get a 98% confidence interval for the proportion who smoke if you want the margin of error to be 3%, 2%, 1%? Note here, we do not know what is the sample proportion. So we are going to assume and make our life simple. It is 0.5. As we're looking at a 98% confidence interval, the critical value is 2.32. Okay. Now, with these things in hand over here, so the question is, where am I getting 2.32? Now, remember, it's 98% confidence interval. This one is, the formula, remember, is Z alpha by 2. Okay. So this one, your alpha is 1 minus 0.98, 0.02, and alpha by 2 is 0.01. Okay, and then we are going to figure out, so we want to find this is Z alpha by 2. So we're going to write down the formula, which is inf norm. Remember that, guys, very, very important. It is going to be INV norm. This is going to be 0.99. Remember that, because this one is 0.01. This is 1 minus 0.01. It's 0.99. And then you're going to get is a 0 and a 1. So when you get your calculators, go ahead and plug in your calculators, guys. You know how to do it now. So when you plug in your calculators, you get 2.32. After that, it's just plugging and getting the answers out. Okay, what's the end formula? It's p hat 1 minus p hat Z alpha by 2 square over E, that is the margin of error. So remember, my margin of error is the same as E square. So p hat 0.5, 1 minus 0.5, then 2.32 square divided by margin of error. Now there are going to be, it's 3%, 2%, 1%. So if it is 3% margin of error is 0.03 square, we get the answer to be 13456. You always increase the number by 1. If you're getting, 1495. That was for this. So this is scenario is, so when you plug in the numbers, you will get 1494 something. By always default, round it up to 1 greater than, round it up to 1 integer. Round up, remember I'm saying. So it's going to be 1494 point something. So you say it's equal to 1495. So whatever the number is, say 3, 4, whatever it is. Similarly, if you have a 2%. So 2% is going to be what? The same numbers. So your n is 0.5, 1 minus 0.5, Z alpha by 2, that is 2.32 square, and bottom is going to be 0.02 square. So when you write down the value, you round it up to, round up, and you get the answer to be 3364. Okay. Similarly, when you have n to be, 1%. So here for 1%, the sample size, just plug in the number. It is going to be 13456. Okay. Now this was for sample proportions. Let's look at sample means. It says the number of ACME lunch boxes produced per day is known to have a standard deviation of 55. Find the minimum required number of days we need to survey to construct a 95 confidence interval for the actual mean number of lunch boxes, which is produced per day, given we require a margin of error to be no more than 15 lunch boxes. So what's the formula, guys? If you remember over here, the formula is 95%. That means Z alpha by 2, which is my 1 minus alpha is 0.95, alpha is 0.05, alpha by 2 is 0.025, and we know from previous Z alpha by 2 is 1.96, okay? So it's Z alpha by 2 times sigma over margin of error, the whole square. That's what it is. Okay, so Z alpha by 2 is 1.96. Sigma is, standard deviation is 55 divided by 15. When you do the whole math square, so you will get, say, 151.64. No matter what happens, round up. So even if that value previously, if the value was less than 0.5, you still round up. So it's an approximate 52. Okay, one more example, and we are done, guys, with this chapter 8 of confidence intervals. Now, the standard deviation of the age of college students is 2.2. So we are assuming here sigma to be 2.2. What is the minimum required sample size to have a 95% confidence interval for the population mean age? Remember the word mean. And we're looking at minimum required sample size. If you want an interval of width of 1 year, that means this is my margin of error. So according to the formula, n is what? Z alpha by 2 times sigma over margin of error the whole square. Now remember, my 1 minus alpha is 0.95, alpha is 0.05, alpha by 2 is 0.025, Z alpha by 2 is 1.96. So it's 1.96. What is the standard deviation? 2.2. And the width is 1. You square it. You are going to get to be 18.59. Round up. That means we get 19. Well, we are done with confidence intervals using estimation of parameters. And then we are going to start next time with hypothesis testing. Thank you, guys.